and I want you to be successful, and it probably will show up on the final as well. So I want you to be okay with those, okay? So don't forget about the rest. So if you're still, I keep on assigning right like compass directions. If you're like, I got it, I need to try the other ones, or I still need to try the other ones, go for it, right? Okay, a plane leaves a Winnipeg. Anyways, there. Leaves Winnipeg, Manitoba towards a Brandon. Sorry. I was definitely rushing on that one. Which is 132.8 miles due west. All right. That is due west is exact, right? Like you're just going straight, like horizontal travel, which is actually pretty sweet. You will see that. And once in Brandon, it picks up passengers and then heads in a new direction, right, to Russell. Like we're going to Russell. Winnipeg to Brandon, then to Russell. We're not told how far we're flying, but then Russell is this far from Winnipeg. As the crow flies, have you heard of that term? As the crow flies is like direct distance. Okay, that's an old saying, and because it does show up in some of the word problems, I wanted you to know that. Okay, direct distance. Sketch a scenario, so we're going to go ahead and do that, and then we're going to do two sketches as I tend to do, right? Interpretation and then clean diagram. And so we're going to do west. Okay, so I'm going to say that this is Winnipeg here, and then I'm traveling straight. Right? I guess I should say Winnipeg, otherwise you're going to think it's west, right? And this is Brandon. Brandon, different city. This is 132.8 miles straight west. Does that look horizontal to you? Doesn't look to me, but just trust me, it's horizontal. And then can I just add that here? Horizontal travel, right? In this case, we're going straight horizontally, which is kind of nice. Once in Brandon, it picks up passengers and heads west. Go ahead, yeah. It's all on the video later. Good luck, by the way. West 63 north. So I'm gonna go right from here. I'm just gonna go west, like the dashed line, because it's just my starting point, and I'm going 63 degrees north, right? So there's a 63-degree north line, and so it's going something like that. So again, you have to be comfortable with erasing. It will happen, right? So there's a 63 degree happens here, and then this is Russell. Okay, Russell. And so we're then, as the crow flies from Russell to Winnipeg, like if you were able to go straight, that would be 381.52 miles. This is all Google Map accurate, guys. I actually spent the time to look this up. So here we have our situation. This one in particular is not too bad, so I'm actually just going to leave it. I'm not going to do a clean version of this. We're good? So what happens here? What can we do? You're smart folks. Tell me. Francis? He's the spokesperson for the class.
Angle R is 63 degrees. You do
So you're saying you're doing some alternate interior business here?
yeah. No.
Well, you can, but you have to be careful. If this is your transversal, if you travel,
Oh wait.
that's the whole thing, right? We can't use that one, guys. Got to use something else. Damon.
The angle for Brandon is 180 minus 6.
Uh-huh. Uh-huh. You know when I tell you at the beginning the straight line, a straight line equals 180, and I tell you it's going to come in handy later? That's why I do it. Then you'll be like, ah, okay, right? So, yes, this was a perfectly horizontal line. We were going due west, right? Like we were going straight horizontally. So you can assume this is perfectly aligned here with the east-west line. So yes, we can find that inside there. I'm going to use a different color. For this one, this is the one I want, right? So what are we at there? 117? Yeah, yeah. So that would be the first step there. I will just make a note here. Supplementary, right? Angles. And I will say why. Since it is along the east-west line. Okay. Probably gonna regret this later. It's gonna use up too much space, but hey, we're gonna make it work. All right, so now we have that. We need at least one angle. We've got that now, and we can get started. Okay, so it says calculate the direct distance from Brandon to Russell. Brandon to Russell is x. Let's call that x there on the diagram. So I have my pair. It happens to be sine law, guys, but it's not always going to be sine law. Hopefully by tomorrow we'll have enough examples, and if you've done your homework, you've probably realized that it's not always sine law. So we've got our pair, and then we need to find, in order to get to our destination, in order to figure out x, we would need that angle across from it, which we don't have. So this one is going to be worth more marks, right? You got to figure out r first. You have to. So we use the 132.8 to get us there. So sine of r is 132.8. So as I said, start working towards what you're actually trying to solve. Start somewhere and the rest will kind of fall in place. And I need to actually work this out because this is 0.3101 dot. And so angle R, sine inverse of that, and angle R of our answer is 18.07 degrees. I shouldn't be boxing this in, but it is important, so it's okay. I will also make sure that x is solved for. So now I'm going to use the same pair that I started with. And as you can tell, it's a lot of work. But now that I have angle R, which is this one here, I can find angle W. Why don't we do that first? I'm going to subtract the two I have. Sorry, you can't see that part, can you? But I'm subtracting 18.07 from it. So 44.93. I want to get to the other part as well. So sine of 44.93 degrees over x. And so x is going to be 381.52. So resist the temptation to not show work, right? You gotta show work. And remember, we're working with obtuse triangles, no problem so far. But that's about to change when we're working with sine law. And we are in miles here. And that's our answer there. Distance between Brandon and Russell. Distance between Brandon and Russell. Okay, what are we at time-wise? We're okay, so I'm going to slow down a little bit. See how much further north is Russell compared to Winnipeg. How would you find this? Francis, you can't answer it. Somebody else has to answer. How would you figure that out? What is it even asking? Right, so we know that Brandon and Winnipeg are here. It's asking how much further north is it? Like how much further to the north are you? How much further north are you? Let's see, height. Yes, Marcus, were you gonna say height? And Jenica gave you the courage to say it, right? Yeah, it's the height. We're trying to find the height. Yeah, it's the height of this triangle. And there's a number of ways we can find it. We can go x times sine of 117, or we can go this side times sine of this angle, whichever one you'd like. So we find the height, right? I'm going to go x times sine of 117. And you're like, why are you doing that? Why don't you just put the number in there? Because I want you to see, right? And how am I getting there? So it's 302.41 times sine of 117. Oh boy. And that is 302.41 times sine of 117. That's what you get when you make new questions. You have to make the key. And this is miles. Okay. D. So this is a fully loaded question. Usually that test will not have something as crazy as this, because if you get one thing wrong, I mean, it's just a nightmare to mark the rest. But a quiz could have it, or AC. Okay? If the plane returns back to Winnipeg, calculate how long it would take at an average speed of 180 miles per hour. I'm hoping you're reading that up there. I'm not. I'm just. So basically, you need to figure out the round trip. Okay. Round trip is 132.8 plus 302.41. Oh, you can't see that because I'm off to the side there. Sorry, guys. Plus 381.52. So you add up the whole thing because you need to know what's the total distance traveled in the first place. And that's about to be determined. So that's 816.73 miles is the round trip. Important to me, but not yet the answer. So this is where chapter 8 comes in a little bit, sneaking that in there. Just various ways of doing it. I would say this. if you cover 180 miles in 1 hour, then how long would it take you? How long would it take you to cover 816.73 miles? Yeah.
How come we have to go from Russell to Brandon back to Winnipeg? How come we can't go from Russell all the way to Winnipeg? The second question he says if the plane returns back to Winnipeg, how long will it take with an average speed?
Oh, I see. I wasn't specific when I wrote it. I was thinking something and I was.
Oh.
What I was thinking is if you take the whole trip, right? You leave Winnipeg, you go to Brandon, then you go to Russell, back to Winnipeg. How long would the whole trip take? So why don't we specify that? I'm gonna go up to D here. How long would it take? And we're gonna assume that's a round trip. Yeah, that's a good point. That's actually a good point. Otherwise, we would just calculate, right? Straight from Russell to Winnipeg. How long would that take? Yes. Mhm. Yeah, that's a good point. Okay, so we cross multiply and divide. So it's 816.73 times 1. Not that we're going to type that in, right? But I like to at least show that. So it's divided by 180. So that would take 4.53 or 54 hours. So about 4.5 hours. I could ask you to state it in hours and minutes, but that's okay. I'm just going to leave it at that. There's one before what I want you to focus on today for homework is these two here. Page 10 to 11, it's called Trig Review C. So there's a mix of compass directions and just regular ones. And then there's some more challenging ones at the end of the book, which I'm going to post the answer key for. One more thing before you pack. We have 5 minutes according to my computer here. I just want to tell you when you come across this so you're not stumped. I think you're going to get it right away. You're a pretty smart bunch. But look at page 26 real quick. If Dawson walks 4 kilometers per hour and Rod walks 6 kilometers per hour. So they're giving you a speed. But it's gonna ask you how far apart are they after 2.5 hours. What do you do with the time and the speed? If you're walking 4 kilometers in 1 hour, you walk 8 kilometers in 2 hours, right? Or 12 in 3 hours. So you just multiply them. Multiply your time. That way you get a distance that you need for your triangle, okay? So if you come across that, that's what you do. All right, thank you guys.